right, we are live.
Wonderful, thank you so much. Hello everyone and welcome back to another edition of Indexer Office Hours. Today is the 13th of June and this is Indexer Office Hours 111. If you are new to Indexer Office Hours, and I reckon I can see that there are a few, love the drum there, appreciate that. I can see a few new faces in the crowd, so I just want to say this is the town square for ecosystem participants to come together to discuss all things that are relevant for indexers. This is a conversation. We love participation, so we'd love for you guys to get involved, and you can do that either by unmuting your mic or texting in the chat box as well. And if you're having any issues unmuting your mic, let me know, and I'll try and get that sorted out for you. As a reminder, this will be recorded and posted onto public channels like YouTube. So if you're concerned about privacy, please bear that in mind. And with that, let's get into today's agenda. So for opening remarks, I have a 𝗨𝗪𝗂𝗧 podcast that I want to give a shout out to. And this is with 𝗨𝗪𝗂𝗧𝗂𝗪. And 𝗨𝗪𝗂𝗧𝗂𝗪 is the head of Web3 protocol research at 𝗨𝗪𝗧. And as many of you know, 𝗨𝗪𝗧 is a core developer at the Graph. And 𝗨𝗪𝗂𝗧𝗂𝗪 is involved in all things research on Web3 protocols, infrastructure, base layers, and consumer applications, all of those things. And he's also known for releasing the State of the Graph, which is a research report that comes out every quarter. And so if you're interested in learning a bit about 𝗨𝗪𝗧𝗂𝗪's background, how he came into the world of crypto, and some of the research that he does at 𝗨𝗪𝗧𝗂𝗪, you can go ahead and check out that particular podcast episode, which I will post in the chat. And I will also post his most recent graph report if you're also interested in hearing that. And with that, I will actually hand over, instead of Anna, because she's unfortunately unable to make it today, I will hand straight over to Juan, who's going to take us into Protocol Watch.
Thanks, Abel. Okay, so we don't have a ton of things to cover in Protocol Watch, but we'll be brief. We have, first of all, for forum governance, 𝗨𝗪𝗂𝗪52, which is the time limit requirements to increase rewards in L2. There was a little bit of like a back and forth regarding a few questions, mostly for vesting contracts for delegators as well as indexers, and again, how it works, how the transfer tool works. In those cases, again, you don't have to wait the thawing period. You just transfer to L2 and just wait for the 20 minutes or so that the bridge needs to process the transaction, and that's pretty much all that you need to do. Again, then you have to kind of like receive it on L2, but that's pretty much all of the things that you need to do. You don't need to wait thawing period or anything else. Then we have I still keep having issues with the push to talk. We have GGP25 enabling substream-based subgraphs. We're going to be discussing a little bit on this topic later, but there's a little bit more of back and forth regarding what's actually needed to enable the substream-based subgraphs, as well as some examples of some of those subgraphs that are already deployed that I think Pedro linked. So yeah, if you want to check it out, you can go ahead and look at the thread. Otherwise, we'll be covering a little bit more on those later. Next up, we have forum research. There's quite an interesting topic regarding additional insights from Web3 rewards emission research. This kind of like compares different protocols as well as native tokens like Ethereum regarding how the emission or inflation is done for those projects. And one of those that has been researched is the graph, and it kind of like highlights how stable and how low the emission is compared to some of the other ones, even if some of those are fixed emissions and others are kind of like dynamic. So it's quite an interesting topic. I would really incentivize everyone to take a look at it. It's quite interesting, and it does provide a lot of feedback regarding how the inflation is done in this particular protocol as well as in other protocols. Then we have for context repository, we have some minor fixes for the L2 transfer tools, which came from the intense testing rounds that we are doing to make sure that everything's working correctly. And then for the little subgraphs, we don't really have anything to say because there are no new releases in any of the big subgraphs. With all that said, I'm going to hand it over to 𝗟𝗶 now to continue with the open discussion.
Wonderful. Thank you so much there, Juan, for the update with Protocol Watch. So as Juan alluded to in his section, there is 𝗨𝗀𝗂𝗧𝗂𝗧, which is enabling substreams-based subgraphs, SBS. And I would like to highlight that, seeing as Pedro isn't here. And the ask there is that indexers be willing to sync these substreams-based subgraphs, as it will be helpful to test them. And Pedro isn't here to speak to that, so I just wanted to kind of flag that. I've posted the links to the forum post, and in the forum post, Pedro has actually gone ahead and linked to a few SBS that indexers can go ahead and straight away play around with. So if you could look at that, that'll be fantastic. And with that, I will hand over to Matthew, who's going to take us into his presentation today. So without further ado, Matthew, feel free to take it away.
Thank you, 𝗟𝗶. Can you hear me okay?
We can indeed, loud and clear.
Great. So today I'm going to talk about Firehose high availability. Actually, that was what I was planning to do. And then it's like, oh, well, I need to talk about substreams too, especially given the discussion about 𝗨𝗂𝗂𝗧𝗂𝗧. So let's go to the first slide. All right, so agenda for today. What are Firehose and substreams? Quick review. The architecture. Then we'll get into the main topic, which was high availability. And let's talk about also 𝗨𝗨𝗂𝗧 and cooperating with other indexers to deploy this stack. All right, so first slide, next slide. All right, so what is Firehose? We've seen this slide in a few previous presentations, so I'm not going to go through this in detail. If you want to know more details about what is Firehose and you haven't heard about it before, then please review the previous IOH sessions where we talk about Firehose. So the main thing here is Firehose is extracting all the data out of the blockchain and dumping it into flat files sitting on disk. And having flat files allows us to do massive parallel processing if you've got an architecture that will support it for things like substreams. Next. So what is a substream? Okay, so when you use Firehose, Firehose sends you the entire block, if you like. With the indexes that are implemented in Firehose, you can actually get it to filter stuff. But in general, Firehose sends you the entire block. With substreams, you can get it to just send just the information that you just want for whatever application that you're building. So substreams are composable. Unlike subgraphs, where every developer has their own subgraph, with substreams, you can actually build on top of another person's substream. So one thing that we're going to need in the future is a substream registry where everybody can see the different substreams that are available. And you can say, oh, I want to build something based on whatever that's already there. And then at least you don't have to understand the details of how that other thing works. You can just build something on top of it. So that's going to be a great thing for developers. They're parameterizable. So if you have a substream that takes parameters, then you can just feed it details. So instead of, for example, getting all token transfers, get token transfers for your specific account. Would be an idea of a parameterizable thing. Substreams are transformable. So that means the output format out of the substream when you request data can be in different format. So most of the time in this, when we're talking about the graph, it's going in the format that's required to ingest into GraphNode. But you don't have to put it in GraphNode. You can put substreams in a sink of your choice. So it could go in MongoDB or Postgres or, just send it out to Prometheus and just generate some charts in Grafana. And substreams are parallelizable. Okay. So blocks are processed in chunks, and then the results gets merged. Next slide. Okay, so the data pipeline for a developer. I'm explaining all this because this goes to understanding how it works so that you know how the implications on the deployment architecture. So what do we got? So we have ETLQ. So this is a standard pipeline of data extraction, transformation, loading, and querying. So the extract process is done by Firehose. The transform, so Firehose is creating the flat files. Then Substreams is reading those flat files and transforming it into the output format that you want as a developer. So the developer decides how they want their output. And then we load it into some storage somewhere. So for example, GraphNode or anywhere else. And then that storage location then provides a query layer, or it doesn't, depending on however that thing works. So ETLQ. So just so you understand where Firehose and Substreams fit into the overall data transformation process. Next slide. So where do you want to store all that stuff? So this is just like a kind of a word storm here of store it in Postgres, GraphNode, key value store, stream it somewhere else, CSV file, wherever. So the amount of different output syncs for Substreams is growing every month. We see developers building new ones. So next. Okay, we've seen this architecture diagram in the past, except I added one new box in here, which is the Substreams tier 2, which is at the middle left side there. So when a user connects to Firehose or GraphNode connects to Firehose, that will then send requests to the Substreams tier 2 to process the chunks of blocks for your substream. The remainder of the architecture looks exactly the same as before. So you can request data through Firehose, which works the same way. Or if you send the substream request, then it will process it as a substream and then evaluate the results. I should be clear, there's one line missing from the diagram, which I kind of left out on purpose. The substream tier 2 does need access to the archive node in case you're doing ETH calls. If you're not doing ETH calls, then it doesn't need access to archive node. But yeah, there's a missing line there. All right, next slide. So let's just go through the workflow, kind of what I said quickly, just in detail. So the user or GraphNode or whatever connects to Firehose gRPC. Firehose chops up the requests into block ranges and sends them to the Substreams tier 2. The block size is configurable, you know, like 10,000 blocks in a chunk. The number of parallel threads is configurable. So if you have more hardware, if you have a cloud, this can go very, very big. If you have a small installation, well, you have less processes. Each Substreams tier 2 runs all the calculations it needs and then writes the results back to the object store. So the results don't go back to Firehose, they go back to the object store. And while it's doing calculations, it's sending progress messages back to Firehose. And Firehose is sending those progress messages back to the user, so you can see where you are in progress. And then when it's done, it sends, hey, all finished. And then the Firehose can then retrieve the data from the object store and send it back to the user. The results remain in the object store for future use. So if the developer comes along an hour later, a week later, and requests the exact same substream, well, guess what? We already have the results calculated. We can just send them back. And since substreams are composable, it's actually cached at the module level. So we're going to see that in the next screenshot. But each module is cached independently. So if a developer builds on top of something else that was already cached, well, great, it will run faster because we can already use those. We don't have to recalculate those pieces that are already available. When running live, so if you're up to the current blocks, then the tier 2 is not used. It just runs the substream as part of the Firehose process. The tier 2 is optional. If you don't have it, well, then you don't get the massive parallel processing. Next slide. Okay, so here's a view of Uniswap v3. So I ran this a couple of weeks back, and this is the output that the developer gets on their screen as the process is running. So you can see the progress indicator. So a dark green bar is it's done. The kind of middle color is it's in progress, and the light ones, it hasn't started yet. So, and the maps are listed on the left. I know the font's a bit small there, but this is just kind of the idea of how it works. So if you run the command listed there at the bottom, and localhost 9000 is actually your Firehose endpoint, your Firehose endpoint with substreams enabled. There is a configuration flag you need for that. If you pass this, then you'll actually see the output, and it'll start using all the CPU you have available. Next slide. Okay, so let's talk about the goals of the high availability deployment. So there's a few different things we want to think about. We have component upgrades. Aragon nodes need to be upgraded. Firehose needs to be upgraded. If in case there's software improvements, we have to rebuild all the blocks. Hopefully that doesn't happen very often, but it does happen from time to time. Of course, things go wrong. Hardware dies. Want to handle that kind of case. And then for the purposes of substreams, the more hardware we can throw at it, the faster it's going to compute a newly created or newly requested substream. Next. So here's when I was running that substream, here's the CPU or the resources chart that I put together. So it's like running, I don't know, 150 odd CPU cores and using 164 gigs of RAM and then the bandwidth to the storage server. So this is just, I added up, there was 4 machines allocated to processing substreams, so I just added up the whole usage. So you can see on the bottom chart is the network utilization going back and forth to the storage server. You can see it's reading all the blocks, but the actual number of writes is actually quite small, at least for this substream. Other substreams might write more data, but the yellow downward is much smaller than the green upwards on that bottom chart. Next. Okay, so just going back to our little diagram from before, just changed it a little bit here to put little boxes behind the things that you have multiple of. So we have multiple Firehose gRPC endpoints, multiple relayers, multiple substreams too. The Firehose enabled execution node, reader, consensus node, those things are a bit, well, I don't know what we call it, weird, because depending on which blockchain you're running, how that architecture looks is dependent on how that blockchain was. If you're running with Ethereum, then you kind of need consensus node, Firehose enabled execution node, and reader as a triplet. So you need all 3 of those as a cluster together. So just to say, the architecture of how the high availability for the blockchain parts work depends on which blockchain you're on. But otherwise, yeah, here we go. Next. So what's the best way to set things up? Unfortunately, I don't have a universal answer for you. It depends. What kind of services do you plan to offer? Are you just using it for your own use, or are you going to plan to make your Firehose publicly available? What kind of environment do you have? Is this on bare metal? Is it on cloud? Lots of different things to set this. There's lots of different ways to set this up. You'll need to help figure out what works for your environment and what services you plan to offer. We're happy to help discuss. I know that a few indexers have set up high availability solutions already. Good discussions in the Indexer Firehose channel, so feel free to ask. Also, this is an evolving tech stack. If you looked at the blog post from Streaming Fast from last week, where they're listing the different things that they're working on for June, then you can see that they're working on evolving the Substreams Tier 2 backend to improve it. So based on the developer feedback, based on indexer feedback, this tech stack will keep improving. And as we discussed earlier, GGP 0025 substreams are coming on the network soon. So hopefully you're interested and ready to run this. Next slide. Okay, storage. Usually you want to keep one copy of the Firehose block. So unlike running a blockchain node where you have to kind of clone the entire infrastructure and you make an exact copy of it, here we're not making a copy of the object store. There's only one object store. And all the different components access the same object store. The object store does need to be shared so that all those different components can access to it. You can run the object store on a cloud provider. You can do it on Ceph like we do. Somebody else runs it on Seaweed FS. Other people are using NFS. Variety of different solutions you could use to run to share data. I mean, you could replicate the Firehose blocks across multiple locations. That also works too. That makes it a very simple setup, but you're not getting the advantages of reusing the blocks across multiple servers. Next. Connectivity. Okay, so let's talk about how do we connect all these components. So probably if you're going to start running multiple Firehose gRPC endpoints to handle load, then you're going to want a load balancer. So in our case, we use Nginx. Other people might do different things. So there's the incoming component where you need to load balance Firehose. There's also connections between all the different components. And then you need a way to distribute load to the substreams tier 2. So you could connect all these things manually, specify the IP address and port, do DNS. We use service discovery in console. You can create a proxy server, or I know other people use XDS with Google Traffic Director or Envoy Proxy or something like that. So depending on your thought process of how big you want to get, it might inform different ways of selecting different things. So we use Nginx as our incoming load balancer to Firehose. Nginx does proxy gRPC connections okay. We are looking at Envoy to how to do the internal routing to the tier 2. But it's not really routing because it's really directing the traffic based on load. Currently, we're using DNS round robin for that, which doesn't exactly distribute the load evenly across the different backend tier 2 nodes. So, okay, next. Okay, so the other thing is maybe you want to run part of the stack yourself and work with another indexer to run other parts of the stack. So the idea going forward as part of GIP 0042, a world of data services, is that indexers are going to come in variety shapes and sizes. So, for example, at Pinax, we spend a lot of time working on Firehose and substreams, and a bit less time working on the kind of quote-unquote traditional GraphQL graph node infrastructure. Other indexers may make, the reverse decision. There may be more opportunities to run more different things in GIP 0042 in the coming years. So in general, it doesn't make financial sense for every indexer to run a full stack of Firehose for all the different blockchains that we're going to ever have available in the graph. It just does, some ecosystems in the graph are just not big enough to make that makes a cost-effective decision. So we need a way to allow indexers to cooperate with each other, and maybe one indexer wants to generate subgraphs on for a certain blockchain, but use a different provider's Firehose, or maybe they want to run Firehose and they outsource the substreams part. So anyway, in the future, we see a lot of different indexers configured different ways depending on which components they want to use on which blockchains. Next slide. So here's just a kind of visual example of kind of what I was explaining. So indexer A has a graph node, and they're running a Phantom archive node and Avalanche node, and they're running an Ethereum Firehose. And the indexer B in the middle is using the Airweave Firehose from indexer A, and they're running their own Ethereum Firehose, and they're using Firehose for Polygon from indexer C. Should be possible. Indexer C is not even running graph node. They're just running a public API for Firehose and substreams, potentially. So this is the kind of architectures that we need to think about as indexers in the future. Next. Other considerations. So hopefully everybody already set up Prometheus. If you didn't, please go back, review previous slides, set up Prometheus. It's going to help you a lot. And I mentioned this other thing before is sometimes we have to reprocess Firehose blocks. So I would recommend that whenever you set up your object store that you stick a version number on the blocks. So we've got the blockchain name, which probably you've already put there, as well as a version number. The version number can be anything. You can just V1, V2, XYZ, whatever you want to call it. But that way you can use your same object store to store a new version of the blocks in case they're needed in the future. Next. Well, actually, that's it. We're at the end of the slides. So if there's documentation is on firehose.streamingfast.io and substreams.streamingfast.io. There's not too much on high availability there, but we're happy to discuss more in the Indexer Firehose channel, and we'll start adding more information on how indexers should set things up in the future. Yeah, that's it for now.
Wonderful. Thank you so much, Matt, for going through all of that in the presentation right there. We have a question from Vincent, which I've highlighted here. So if you want, you can go ahead and address that one there.
So how important is it for the speed the Firehose gRPC is close proximity latency to substreams? Can you get away with higher latency? Well, so yes, you can get away with higher latency there. The key thing is that both Firehose gRPC and the substreams are going to use those block files. So the really important part is they both have access to the blocks. Now, if substreams has a bit of latency on accessing the blocks, the tier 2 node, not too big a deal. It's just going to process it a little bit slower. But you do need to watch out for the bandwidth costs. So you probably don't want to store your blocks, for example, in AWS and run, your substreams tier 2 in Hetzner, because, the egress costs out of AWS would kill you. So, look at the cost that. But you can ask, is there another question? Maybe a follow-up question if you want more details. So the whole point of substreams tier 2 is to support the massive parallelization. So if you looked at some tweets recently or, Alex's blog post from last week, we processed Uniswap v3 and loaded it all into GraphNode in 20 hours. Yeah, that's cool, loaded in 20 hours. But how many tier 2 nodes were required in order to make that happen? Well, quite a lot. I don't know exactly how many, but you can see we had, a lot of CPU cores allocated to that. And I think ours took a bit longer than the Streaming Fast team. I think, I'm not exactly sure how long theirs took. I think theirs took like 10 hours or something. And ours was probably more like 15 or 20 hours. But anyway, so look at the number of tier 2 nodes you want to deploy just directly correlates to how fast you can process a substream-based subgraph. The 20 hours was with GraphNode, but using GraphLoad, I believe. So GraphLoad is the way of you run Firehose substreams, you dump all the output into basically a CSV file, and then you bulk import it into Postgres. Okay, where else what other questions did I miss?
There's quite a few. We've tried to label them with questions. So I think Pranav is the next one.
Pranav is next one. Okay, do we need archive node calls with substreams? Since Firehose do not do archive calls. Okay, so if your substream uses ETH call, then you do need an archive node. If your substream does not use ETH call, then you don't need an archive node. So that's the requirement. So eventually there will be this we've talked about before, this thing called EVMX. EVMX just stores all the results for the archive for the ETH calls, So in that case, you wouldn't need an archive node. But not for now, yes, you still need an archive node. So you need to hook up Firehose to the archive node as well as the substreams tier 2, both to the archive node to process ETH calls. If you're doing Firehose and substreams on a non-Ethereum blockchain, so say, for example, Cosmos, then this concept doesn't exist. You don't need an archive node of Cosmos in order to process substreams on Cosmos. Would you say latency between normal subgraph? Would you say latency between normal subgraph graph node and archive node is more important than latency between Firehose, gRPC, and substreams? I would say yes. But I don't have data that proves it one way or another. When Wreath Firehose? Don't know about that one. There is a project to work on Aragon Firehose, but Wreath Firehose, don't know anything about it.
Have you tried Wreath?
I have not tried it. Is it good?
Apparently.
Yeah, so keep us, for those of you who are trying Wreath, keep us informed. Let us know how it's going. I'm interested. I just haven't tried it yet because this weekend I was playing around with 𝗨𝗀𝗂𝗧 since it was just released, rather than that. Does EVMX implementation requires changes in the blockchain node client? No. EVMX is populated from Firehose itself. So the data goes from Firehose into EVMX. Any recommendation on the maximum number of tier 2 jobs versus the number of tier 2 nodes? I think about 20 jobs per node, if I remember correctly, is the recommendation. So if you've got a full machine, then you can support. Well, it really depends on the amount of CPU cores, of course, you have. So, but yeah, you don't want to like put, say you have a machine with 100 CPU cores on it. You don't want to probably just have one tier 2 node on that. But definitely you want to have enough parallel processes to use up all the CPUs that you have. So on my 50 core machines, I had like 2 or 3 tier 2s, I think, and then I ran like 300 threads. Any other questions? Seems like we're out of questions for now. So Abel, I'll hand it back over to you.
Amazing. Thank you so much. Yeah, and if anyone has any additional questions, as you can see here, we can continue the discussion in the Indexer Firehose channel in the Discord. So I'll just Indexer Firehose. There we go. So people can navigate towards it. Cool. Payne, you wanted to talk about some Polygon stuff. So if you want, the floor is yours.
Yeah, so our node just crapped up last night. It was just giving us an error that found a bad block, so it rewinds to it, and then it doesn't have, like, it cannot find any block headers basically afterwards. Exactly. Thank you for that. But I managed to rewind it a couple of blocks somehow. Its automatic rewind didn't work, but the manual rewind seems to have done something, because I see execution stage went past that block. Unfortunately, I think it won't be able to catch up to Chainhead until this call ends, so I can't really keep you posted on that. But maybe next week's IOH we can talk about it. But yeah, if it works and if it's fine, then I can just post the command. Well, it's very simple. You just need to give me 1 second. So you basically need to run integration state stages and unwind by 10, and it worked for me. With integrity false equals false, fast equals false. Yeah. But yeah, I'll keep you posted. I have a feeling it's not gonna work somehow. I don't know why. But fingers crossed. And yeah, Polygon Aragon definitely needs constant backups. That's why once I'm done building my home servers, I'll be using ZFS and a huge JBOD. Oh yeah, ZFS for the win. That's true. Well, Matthew, by the way, can we chat just a tiny bit for 1 minute about the consumer hardware stuff? Because I was looking into this, but like, I know you've managed to run UDA2 NVMEs on a consumer platform, but my problem here is like I can't use ZFS if I'm using consumer hardware, because we're limited to 128 gigs of RAM. So yeah, either
Why
Threadripper.
why does ZFS not work on 128 gigs of RAM?
Because if I want like 100 terabytes NVMEs, then yeah, well, 100 terabytes total. ZFS
Well,
usually needs like one gigabyte of memory per 1 terabyte of storage.
right. Oh,
So yeah, you'll be
I get.
limited to like 20 something gigs of RAM for whatever you're running on that machine. So it's definitely not a good idea.
Yeah, so I guess in our setup, the nodes that have the lower amount of RAM on CPUs that are high frequency don't have that much storage,
Fair
right?
enough.
So
Okay.
they would have like two 14 terabyte disks,
Yeah.
and then you run a ZFS on it, and it works fine.
Fair enough. Yeah. Yeah. I'll stick with 96 core epics. Yeah.
Yeah, our hardware setup is a wide variety of different stuff.
Yeah, I'm gonna buy a bunch of consumer hardware as well eventually, because I also want to experiment a little bit with running the DB somewhere else with like a higher clock and stuff like that. But we'll see. Like for now, I think two single epic or one dual epic servers with 96 cores each CPU. I think should be fine, and 3 terabytes of RAM.
So we actually have some Xeon W machines, which are you can put up 512 gigs of RAM, and the CPU frequency is much higher than a general Xeon machine, but
Interesting.
pure cores.
Mm-hmm. Good to know. Hey, we got an unrelated question. Are people running 0.31.0 in prod for both Arbitrum and Ethereum mainnet? I think I do. I think I still, like in prod, I still run the RC one. So I'm gonna have to update. I can check really quick.
Sweet. Seems like
I forgot it even released, to be honest.
There was quite a bit of delay between the release candidate and the final release, so we all forgot.
seem
Since we have a bit of a pause here, I'll take this moment to make a quick announcement, which is that we're finishing up a big project on the indexer agent to support multi-network indexers. So you can have one indexer with a single graph node or graph node cluster and a single database, but operate on multiple protocol networks. So you could be on, for instance, 𝗨𝗲𝗂 and 𝗨𝗏𝗪, or mainnet and Arbitrum, or 4, or as many as you want. And you define like your network, your configs per network in the indexer agent. And the agent works in the same way as it was before, but it'll operate across all the networks. We're finishing up that work today, and I'm going to probably post in the testnet channel tomorrow, maybe later today, and ask for people to test it. So if anyone is available, especially if you're already operating across multiple networks, or if you just want to try it out, I would appreciate any testers this week.
How good is it for straight to production testing? Let's say. Should we put it there or try with testnet first? I know I'm a DJ, but yeah.
I just started testing it like a day or so ago, and I have run it on my local machine, configuring across 𝗨𝗪 and Arbitrum 𝗨𝗪, and using indexing rules to create actions and then improve those actions and take action on the network, and it's been working well. So
Okay.
I think you could go for it. As always,
YOLO.
Caveat, you're YOLOing into it. There's some danger there for sure.
So Vincent posted a great idea, straight to production on manual, maybe. Yes, I've been using it, all my agents on manual, because I don't trust them. But yeah, I think I can.
I use oversight mode, which I like a lot, and that allows the agent to still use your indexing rules to queue up actions. It just won't take them on its own. You have to, explicitly approve them for them to be taken.
Do you find that useful? Because most of the times when I reallocate, I usually go with so different subgraphs, and it almost never reallocates to the same, or even yeah. And I also prefer usually just clearing up all the queue and starting from scratch with like just a fresh new queue, and so yeah. Maybe it's just me.
I tend to agree. Like in general, when every month, I totally reevaluate which allocations I'm going to do, and I use the allocation optimizer, and so I don't usually use those automated reallocations. But it is kind of nice that the agent's just queuing those up if I did want to use them. So yeah.
Yeah, that's awesome.
So I am running, so at ANN we have our more profitable focused indexer, and we have the backstop, more like subsidized indexers. It just is syncing all subgraphs. On the backstop indexer, I just use global rules to allocate to any subgraph with some minimum signal threshold. I think it's like 10,000 GRT right now. So on that one, the automated, like the oversight mode is vital. Like I don't want to manually be managing 300 subgraphs and 300 allocations.
Fair enough. How big is the database on the backstop indexers, by the way? Because I already I have like 500-ish subgraphs, and it's already gone past like 17 terabytes, I think.
Oh wow, I think it's about half that, but I would have to double check.
I'm super curious. So yeah, maybe let's catch up after the call.
Yeah, so I'm pretty excited. Like this new feature will allow me to run a backstop indexer, just one instance with all subgraphs on it, and just allocate across all of our networks.
Yeah, that's
gonna
be cool.
Be a huge upgrade for anyone that's trying to do that, and just make that a lot easier.
Dude, I can't wait for all the subgraphs to migrate to Arbitrum, because then it will be super cool to just allocate to like 500 of them for the same cost of 20 on mainnet. Because like one of the reasons why I'm also buying so much hardware and like syncing so many subgraphs is that I want to support them eventually, but like on mainnet allocating to 500, it's gonna be costing me a liver and a half.
Yeah, it's going to be amazing being on Arbitrum. It's hard to overstate how much of an efficiency increase it is. Like I think it's like 30x improvement as far as ETH used for transactions.
I think maybe even more, but yeah, it's
Maybe,
amazing.
yeah. I think that's like maybe low end.
I see a question. Will it support different indexer addresses for different networks? Because like maybe
Yep.
some people. Oh, okay, yeah. So maybe some people choose to migrate their existing mainnet stake to a different address on Arbitrum.
Yeah, you can use totally different addresses. And I think this actually ends up making it's like a nice improvement as far as configuring the indexer agent, because it's now the concept is a separate specification or a config file per network. So we have a new YAML file structure for configs. And I think it just makes it a lot clearer and easier to set up the configs per network. And in those configs, you would include some of the typical things like indexer address and mnemonic and operator address, as
Nice.
well as like provider URLs and subgraph IDs and stuff like that.
That's cool. And also one question from me. I guess do we still need multiple indexer services, right?
Yes. Right now, the indexer service has been changed minimally. The idea would be you would still have multiple, but those could just all proxy to the same graph node cluster.
Oh yeah, of course. Yeah.
Yeah. Yeah.
Would it be nice? Would be nice to eventually have those like put together the same way we have the agent now, but I guess it's not the big priority. The
Yeah.
priority was the
Totally agree.
pain in the ass to manage subgraphs, which is totally gonna be sorted out by this. So it's amazing.
Yeah. And then like another big thing is the L2 migration. So we're trying to think through ways that the subgraph migrations from L1 to L2 could be no downtime. And the only way that's going to work is if indexers that are pick up that subgraph on L2 already have it synced from the L1.
Mm-hmm.
So as we get this release out, I'm going to start trying to push more indexers to use it, and especially if indexers are migrating their stake over from L1 to L2 and then maybe in a staged approach, they can use this tool and automatically support that subgraph migration. So we're going to add a feature so that your agent will allocate to that subgraph as it moves to L2, so you immediately can support it. The more indexers we can get using this, the better for the migration process it's going to be for developers, so that they can just migrate over using the transfer tools and immediately be supported on L2. But we're also doing some things in the gateway to try to make that smooth. So the gateway will forward L1 URLs to the L2 gateways for a while, so that people that are still trying to query the old subgraph on L1 will have a smooth experience. And but yeah, the more indexers we can get that are straddling L1 and L2, I think we can make the best experience possible for people that are migrating their subgraphs.
Vincent says, currently I have to shut down an index agent on one chain whenever I want to do anything on the other. So I'm looking forward to this update. Well, yeah, you could like there were ways to go around this even beforehand. Basically, just keeping a unified off-chain sync list and then running both agents so they don't collide with one another's actions. But you didn't have to shut them off. And there's another question. So indexers on L2 will have to keep some stake unallocated for those auto allocations, right? Wouldn't be much of an issue, but good to know.
Yeah, and like I said in the chat, I think that that's one thing that there's not like a perfect solution for. So I'm open to ideas you guys have, but right now I was basically going to allow you to set a global or basically like a default rule for L2, and then whatever allocation amount you have in that default rule will be used for those new auto allocations. Open to other ideas, like if like I could imagine there being a startup parameter that's very specific to this for these L2 allocations and setting what the allocation amounts are going to be. Yeah, like anything we do like this where it's automated allocation, we're going to run into issues where it's not necessarily the exact allocation amount that you want, but I want to try to get it as close as we can. And yeah, a big part of this effort was to make it so you didn't have to manage like the subgraph deployments and offline sync lists across multiple agents, because it's just making sure those are in sync is a pain. And if you don't have them in sync, your agents are going to be fighting each other, deploying, undeploying subgraphs.
But like, if you guys are running backstop indexers, and also I know P2P is also running some, I guess that should be enough on Arbitrum to enable like a quick migration, especially if they're using the same DB as the production subgraph, production indexer.
Yeah, yeah.
So I don't think we should worry that much about this, but it's good to have.
And then we don't have support for it built into this current PR that we're submitting this week. But another thing that we can do down the line is have support for multiple indexers on the same protocol network.
I was just about to suggest, how complicated would that be? Because I run a bunch, and I hate to see like 100 index agents there. Not 100, but you know what I mean.
I honestly don't think it'd be very complicated. It's like a very similar concept to having multiple agents and multiple networks. It's like, I think all of it's going to be about the same. I just have to verify things. Like right now, I think there's probably some validation that says, if you define the same network in multiple config files, it'll error out. But yeah, basically, I think this concept can be applied there pretty much directly. I just have to do a bit of research to make sure it works.
I would love that.
There's a few other indexers that are managing stuff like that too that would get some benefit from that. So I'll definitely have that on our list of next things to do.
Awesome, thank you. I see Vincent says we're running into some issues even with a unified offline sync list. So we only have one agent running at a time. Really? I've been running this particular setup for like, I think almost 2 years now. And I haven't had any issues. They're like, the issues that I've had were like just agent bugs in general, not related to running multiple agents on the same machine. But I have, so the way we run it, I have different Postgres instances, like not even databases, literally a new VM or a new container for each of those agents. So they don't they don't interfere with one another at all. But I don't know if that changes anything per se, because like even if technically if you connect them to a different database within the same Postgres instance, they should not have any issues. But yeah, I don't know. Yeah. Oh yeah, that's true.
So there'll be some interesting UX issues, I think, to make this smooth now that we'll have multiple networks on the same agent. Like making sure logs are super clear between the networks, maybe even making it easy to pipe logs to different places, and just like working through some of the kind of extra cognitive load that'll come from everything being in one place. But looking forward to feedback from people that test it.
How does it handle logs right now? Does it say whichever, like in each line of logs, does it say something about the network? Or how do you differentiate between the networks?
Yeah, we basically have this concept, this label of protocol network, right? So the subgraphs have their indexing network, and then we have the protocol network of where you're allocating. Like, is it on Arbitrum? Is it on mainnet? And our logs are JSON structured, and we've tried to include the protocol network label in pretty much all the logs or all the relevant logs. So, it's possible we've missed places, but the idea is that every log would come with a protocol network, so you can quickly know where that's happening. And then with that, you could filter your logs. You could filter them for protocol network equals whichever one you want to see logs for.
Nice. Okay.
All right. Does anyone have any additional questions, thoughts on what was just said there? And by the way, this was amazing. And another reason why it's important to show up every week for Index Office Hours, so that you can get these hot off the press releases and announcements. So yeah, thank you for sharing forward. Really appreciate that. Exactly. Indexer alpha hours. I love that. These sound effects are amazing.
My name is Jeff.
Oh gosh, I'm crying of laughter. These are amazing. Okay, well, if nobody has any more additional questions, I want to say a massive thank you to all of you for attending today's conversation. And yeah, as all of you already know, this will be recorded and posted onto YouTube. So if I know that there was someone in the chat saying that they couldn't get access, so yeah, feel free to check out the YouTube channel, and it will be up there shortly. Cool. Thanks everyone, and we look forward to seeing you all again next week. Take care, guys. Bye bye.
Thanks, y'all.